The Sun is a G-type main sequence star, G2V. The Sun's mass is about 330,000 times that of Earth. The Sun's gravity keeps all the planets and other objects in the solar system in orbit. It's about 93 million miles away from Earth. The Sun's volume is so vast that more than 1 million Earths could fit inside it. If you could drive to the Sun at a constant speed of 97 kilometers per hour, it would take over 176 years to get there. The Sun's luminosity is approximately 386 billion megawatts. Solar flares can release energy equivalent to 1 billion atomic bombs. The Sun's core is incredibly dense, with a density about 150 times that of water. The Sun's outermost layer is the corona, which is much hotter than the surface. Solar energy output is not constant and varies over an 11-year cycle. The Sun is made up of roughly 74% hydrogen and 24% helium. It also contains trace amounts of other elements like oxygen, carbon, and neon. The Sun rotates, but different parts of it rotate at different rates. At the equator, it takes about 25 days to complete one rotation, while at the poles, it can take over 35 days. The Sun's equator rotates faster than its poles, a phenomenon called differential rotation. The Sun has no solid surface. It's a ball of hot, glowing gas. It's estimated that the Sun is about halfway through its life cycle. The Sun's gravity is 28 times stronger than Earth's. The Sun's core temperature is hotter than the surface of any known planet, about 15 million degrees Celsius. Solar eclipses can occur when the Moon passes between the Earth and the Sun. The Sun's energy is produced through nuclear fusion, primarily involving the conversion of hydrogen into helium. It takes millions of years for energy to travel from the Sun's core to its surface. The Sun's core pressure is approximately 250 billion times that of Earth's atmospheric pressure. Solar activity, like sunspots and solar flares, is driven by complex magnetic interactions within the Sun. Sunspots are temporary dark areas on the Sun's surface caused by magnetic activity. The Sun's surface temperature is about 5,500 degrees Celsius. The solar wind is a continuous stream of charged particles, primarily electrons and protons, flowing from the Sun's corona. The solar wind can travel at speeds of up to 700 kilometers per second. Solar flares are sudden bursts of energy and radiation from the Sun's surface. Coronal mass ejections are massive eruptions of solar plasma and magnetic fields into space. The solar corona, or outer atmosphere, is much hotter than the Sun's surface, reaching temperatures of millions of degrees Celsius. Prominences are large, looping structures of plasma that extend from the Sun's surface into the corona. The Sun has a north and south magnetic pole, just like Earth. The Sun's magnetic activity can affect Earth's magnetic field and cause geomagnetic storms. Solar wind interacts with Earth's magnetosphere, leading to phenomena like the northern and southern lights. The Sun emits a continuous stream of neutrinos, which are nearly massless, electrically neutral particles. Neutrinos from the Sun pass through the Earth and everything on it, making them extremely difficult to detect. The Sun contains more than 99.8% of the total mass of the entire solar system. The Sun's gravity influences the orbits and movements of all objects in the solar system. The Sun's gravitational pull is responsible for keeping planets and other celestial bodies in orbit. The Sun's influence on the solar system extends far beyond the planets. It also affects comets, asteroids, and space debris. The Sun's gravity helps maintain the Oort cloud, a region of space containing billions of comets. The Sun's energy powers the solar system, providing the heat and light necessary for life on Earth. The Sun is the central reference point for astronomers measuring distances and positions in the solar system. The speed of light, approximately 186,282 miles per second, is used to measure the vast distances within the solar system. The sun's light takes about 8 minutes and 20 seconds to reach Earth. Solar radiation pressure from the sun's light can affect the motion of objects in space. The sun's gravitational influence extends to the outer reaches of the solar system, where it affects the orbits of distant objects like the dwarf planet Sadhana. The sun's position in the sky changes throughout the year due to Earth's orbit around it, resulting in the changing seasons. The sun's apparent size in the sky is nearly the same as the moon, which is why they can occasionally appear to be the same size during solar eclipses. The sun is used as a reference point for measuring the brightness of other stars. This is called the apparent magnitude scale. Astronomers use a different scale called absolute magnitude to compare the intrinsic brightness of stars, regardless of their distance from Earth. Solar telescopes and observatories, both on Earth and in space, constantly monitor the sun's activity. The Solar and Heliospheric Observatory, SOHO, is a spacecraft designed to study the sun's interior and outer atmosphere. The Parker Solar Probe is a NASA spacecraft that has been sent to study the sun's outer atmosphere and the solar wind up close. The sun's rotation can be observed by tracking the motion of sunspots across its surface. Helioseismology is the study of the sun's interior by analyzing its seismic waves, similar to how seismologists study Earth's interior. Solar radiation provides the energy needed for photosynthesis in plants, which is essential for all life on Earth. The sun's energy drives the water cycle, influencing weather patterns and climate on our planet. Variations in the sun's output can affect Earth's climate and contribute to phenomena like ice ages. The sun's energy is harnessed for various purposes, including solar power generation. Solar panels use photovoltaic cells to convert sunlight into electricity. The sun's rays are a source of vitamin D, essential for human health. Sunlight has been used for therapeutic purposes, such as treating certain skin conditions. The sun's gravitational pull on Earth causes tides in the oceans. Solar energy is a renewable and environmentally friendly source of power. Solar storms and solar flares can disrupt communication and navigation systems on Earth. Solar radiation can have harmful effects on human health if not properly protected against. The sun's magnetic activity can influence Earth's magnetic field, potentially affecting compasses and navigation. Solar energy is harnessed not only on Earth but also on some spacecraft for power generation. Understanding solar activity is crucial for predicting space weather and its impact on satellites and astronauts. Advanced spacecraft and telescopes will continue to monitor the sun's behavior and improve our ability to predict solar storms. Solar power technology continues to advance, making it an increasingly important source of clean energy for the future. Scientists are studying the potential of nuclear fusion as a clean and virtually limitless energy source, inspired by the sun's fusion process. Solar energy is being integrated into a wide range of applications, from powering homes to charging electric vehicles. The study of solar physics remains a dynamic and evolving field of scientific research. Solar scientists are working to improve our understanding of the sun's impact on space weather and its effects on technology. Space agencies worldwide are collaborating on missions to explore the sun and its influence on the solar system. The sun will continue to be a central focus of scientific exploration and technological innovation in the years to come.